All right, today we will be covering the, what do you call that? Lesson 42. Okay, worksheet at 37. I noticed quite a few of them have not done their work. Okay, for those who have done, you need to catch up with corrections. And some of them leave it blank. I'm not too sure why. Probably when you go through, you will pick up here and there. All right. Okay, so we are going to do revision topic like what we had done previously. So for those who have not done, I will try to cover as much as possible, okay? All the worksheets that we are supposed to do. So the HCF for question 1, HCF and LCM of the three numbers, okay? This one is already covered like in the early terms already, okay? So wait a while, let me admit the students. Okay, so I have here the HCF and also the LCM of three numbers, 18 and this respectively, and you are given two of them, 54 and 126. So meaning to say the third number is unknown. All right. So usually what we need to do is to list down. So I have a 54, I have 126, and I have something as a third number here. So we will express them into first thing, prime factors. Okay. Find the prime factorization of 54, and then 3933. So what you have here is 2 to the power of 1 and 3 to the power of 3. Okay, so for 126, you also have to list down. Okay, so you have 2, 9, 14. You will have 126 as 2 multiplied 3 to the power of 2 and 7 to the power of 1. Okay, so I also indicated 1 because I just want to make things easier later. And the third number we wouldn't know yet at this point in time. Okay, I should write it on the first page. I should write it here. Sorry. 3 to the power of 3. I have 126, 2 to the power of 2. Okay. And then I have 7, right? 3 to the power with and 7. And then the third one is unknown. Okay. So for this LCM, I have to list it down. The LCM and the HCF. So since the LCM is 18, so I should have a 2 multiplied by 3 to the power of 3. I also express them as a prime factorization. So for the this one is HCF, 2 to the power of 2 times 3 to the power of 3. And my LCM is this. Okay. 18. So 2 to the power of 3 to the power of 2. Okay. So to find back the unknown, what happened here is I want to make use of the information below here. Since I have, give me a minute. My HCF is 2. Okay, so this one, it probably be a 2, right? And then if I look at this, LCM has a square, so my highest power must have a 2. So I have to put it here. Okay, no doubt this is a 1. Now I have a 2 to the power of 2 and 3 to the power of 3 for both of them. So I'm quite safe to put here as 3 to the power of 2, which is the highest, the lowest lah. I pick the lowest because the HCF is 2. So I have to do this. Okay, so just to indicate the difference. Then I don't have anything else. I have 7. Yeah, 7 is already here. So I don't have an 11. So I just put the 11 here. Here, here. Okay. So what I have here is 2 to the power of 2 and 3 to the power of 2 multiplied by 11, which I'll get down to 3 and 2, 4, 9, 11, which is 396 here. It's the third number. Okay. This one is playing around with the powers lah. Okay. 11, 10. Okay. All right. Question? Yeah, I know if there's any question you need to clarify here. This one is a typical type of question that papers usually test. Okay. Next question. Okay, let me erase all this. All right. Question number 2, you are supposed to estimate the value of this, giving your answer to one significant and show your workings clearly. Meaning to say, you are first to estimate the value lah. Showing workings means what? You are not allowed to use calculator. Okay, I understand that. Yeah, because students also tell me over the chat, yeah, that you all have. Yeah, that's why I understand, huh? So as we go along, if you pick up the knowledge here, also try to do the key in the worksheet there also, if you have the time lah. As you do, then you key in, key in, key in. Don't worry whether it's a late work or not. Okay. Question number 2. Now, when he asks you to estimate, giving your answers, so you have 6. Wait, 4.5. 4.5 is 5 minus 2. Okay. Showing all your workings. So what you have is 4, 6. Okay. Now he said to one significant figure, right? So this asking for one significant figure, probably I will look at this. In order to go to one significant figure, I must have 2 of them. Right, not 1, 2, 2 decimal, probably. Okay. 4 point. Okay lah, 4. Okay, here, sorry. 2 significant figures, at least up to. So when you have 4.5 is around 4.6, and then you minus 2.4, right? And you get 2.2, you plus 1.2, you get 3.4. So one significant figure, if you were to round it off, will be 3. Okay, and because they want you to show the working clearly, so you show the rounding off first, estimate first. Okay, so you get 3 in the end. This is to 1 SF, as required by the question. All right, next question is to estimate. Okay, if you are asked to estimate, that means you don't use calculator. So you have to do something which is very near to whatever can be done. For example, when you have a 50, the nearest one, you can convert it to 49, right? So it will be estimated lah. Convert this to the nearest one, it will be 49 square root. Because 49 square root is 7. Okay? Then another thing is, you have a cube root of 9, and the nearest cube root, the perfect cube number, is 8. So I put here, nearest perfect cube number. We learned this before, cube number. Okay, and this get down to 2. So now you have 50 minus 1 divided by cube root of 9. What we can do is to change this nearest. We don't put equal first, all right? Minus 1, bracket. Change it to 8. And now you can put equal sign. 7 minus 1 divided by 2, 6 divided by 2, and that get down to 3. Rounding off, estimation. Okay, all right. Any questions so far? If you don't ask question, I will assume all correct and deem as perfect. Okay. Next question. May I have question number 3? Okay, question number 3. You see, you have to follow closely for question number 3, huh? All right. Oh, what is this question number 3? Expressed as a single fraction, and it must be simplest form for this aspect. Okay, so let's take a look at question number A. You have 2 wholes, 3a minus 1 over 2. To make it into single fraction, I have to make them into common denominator, right? So if I put them into 2, here must be 4 out of 2. And this is over 2, 3a minus 1 will remain. Remember when I say that when you want to do single fraction, we always bracket all the basket, right? Basket meaning all the numerator. Why is it so? Because what I need to do is to do this. Let me highlight this to you. I have a negative sign. Anything negative, we always want to put basket. But for me, I would say whether plus or minus, you put all into basket. That means brackets. Okay, so I have to put it back to this single fraction. All right, so from here is to make them into common denominator. All right. I am repeating all this is because I will still have students asking me, what mistake they make in between the line. So I'm going through with that. I want to put back the basket also. Okay. When I put in the basket, what I can do is this over 2, right? So I expand. I want to do this. Many students did not understand how is this done. Okay, until yesterday when I teach one student last lesson, another lesson, asked me this, how to expand, how does it work? Now, actually, when the bracket of 3a minus 1, outside is a single, it's a one basket by itself. So I can have a minus 1, then multiply by 3a minus 1. Okay, so that this basket is a negative basket. So in order to expand this, is actually multiplying minus 1 multiply by 3a. And I get down to minus 3a. Okay, so another thing here, I have a minus 1 to multiply by negative 1 inside. And that's where I get my positive 1. Okay, so my positive 1 will be here. Okay, so let's get down to here. Here will be negative 3a plus negative 3a. Okay, so my 4 stands alone here. So I have 4 minus 3a plus 1, right? So I can actually have 3 minus 3a over 2. Wait, 5, sorry, not 3.